Good morning, students. Today we are going to read acceleration in the topic of kinematics in the subject of O levels. So concentrate yourself. We are going to start now. First, the definition of the acceleration. Acceleration is the rate of change of velocity. The SI unit for the acceleration is meter per second square. So this is the definition of the acceleration. In other words, if the direction and or speed of a moving object changes, the object is acceleration. So there are two things that are important. If the speed is changing or if the direction is changing, the body will have acceleration. Thus, if an object is moving at a constant speed but changes its direction as it moves, such as whirling a stone attached to a string, so this is the first case, that is moving at a constant speed but changes its direction, will have acceleration. The second case is if object is moving in a straight line, so it means direction is not changing but changes its speeds. For example, he move with greater speed, then with slower speed, then with maximum speed, then like speed is changing but direction is not changing. In this case, body will also have acceleration. So there are two cases: body moving with constant speed but changing direction, and other case is body is moving in a straight line but changes its speed. In both cases, body will have acceleration. A formula for finding the acceleration is change in speed over time taken. So this is the formula, and in simple form, A is delta V. Delta V is change in speed. So look now, delta V is change in speed and time taken is delta T. So A is delta V over T, and delta V is actually final minus initial speed. So V minus U over T. V is called final speed, U is called initial speed. So look now, U is initial speed and V is final speed. So this is the formula of the acceleration. An exam tip for you people is a misconception for acceleration is that many candidates think that acceleration must be zero if an object is at rest. This is not always true. So a case of zero velocity but non-zero acceleration is when an object is thrown upward, it is momentarily at rest at the highest point. The velocity is zero at the highest point. However, it is a free-falling body as the gravity is the only force acting on it. A body is said to move with uniform acceleration if its rate of change of velocity with time is constant. So this is the definition of the uniform acceleration if the rate of change of velocity with time is constant. Here are some equations that will be used in finding the acceleration and in solving the questions. The first equation is V is equal to U plus AT. Second is S is equal to UT plus half AT square. Third is S is equal to U plus V over 2 multiplied by T. And the last one is 2AS is equal to V square minus U square. So here comes a question. A bus starts from rest. So if the bus is starting from rest, initial velocity will be 0 and achieves a velocity of 20 meter per second. So V is 20 meter per second in 10 seconds. So time is 10 seconds. While moving westward from starting point O, calculate the acceleration. So A is the requirement. So according to this data, you may see this equation is used. V is equal to U plus AT because all things are given. So this equation is used. And now acceleration is the requirement. First V will be subtracted from U and then T will go to the denominator. So A will be equal to V minus U over T. So this is the other form of the formula. Now we will put the values into the formula and solve it on the calculator. Will give us the value of the acceleration. The unit for the acceleration is meter per second square. And other question is here, what must be changing when a body is accelerating uniformly? So if the body is having acceleration, the thing required is the velocity must be changing. So look now, the velocity of the body must be changing. So D part is the answer. And other question is here, a sports car traveling eastwards at 30 meter per second suddenly comes to halt. It means initial velocity is initial velocity is 30, comes to halt, it means final velocity V is 0 in 5 seconds. So time is 5 seconds, acceleration is the requirement. So V is equal to U plus AT, the equation will be used because all values are applied in this formula. From here, A will be equal to V minus U over T. Putting the values into the formula will give you the answer. Minus sign is showing that acceleration is negative because body is stopping from high speed to lower speed and finally come to rest. So speed is decreasing, so acceleration will be negative. The negative sign shows negative acceleration. It is also called retardation or deceleration. And other question is here, advertisement for new cars often make claims like 0 to 60 km per hour in 10 seconds. What are these figures a measure of? So if you ever have seen this kind of the advertisement for any kind of the vehicles, this is showing actually the changing of the speed or velocity. So 0 to 60 km in 1 hour. So changing of the velocity is actually acceleration. So these kind of the figures actually show the acceleration of the vehicle. The second question is, the owner of the car says that he can maintain the acceleration of his car at 1 meter per second square throughout a journey. Is this really possible? Explain. So this is a case which is possible only in a very particular case, that is constant acceleration is a proposed form of the space travel. So whenever space travel is concerned, it entails that the propulsion system of whatever kind operates continuously with a constant acceleration. So first, for the first half, when the rocket go up, they go with the constant velocity, and when they, after going to the point, they go to the downward position with a constant retarding velocity, slowing speed. So look now, it entails that the propulsion system of the whatever kind operates continuously with a constant acceleration. For the first half of the journey, it constantly pushes the spacecraft towards its destination. And for the last half of the journey, it constantly uses back thrust so that the spaceship arrives at the destination at a standstill. If a system like this is developed, then it is possible. And other question is here, a car takes 2 seconds to pass point P. So here is the point P. So it requires 2 seconds to pass points P. Later the car reaches point Q. The car takes 0.40 seconds to pass point Q. A car of length 6 meters accelerates from rest along a straight road as shown in the figure. So it means to pass point P, the distance traveled must be 6 meters because the length of the vehicle is 6. So it means time is given 2 seconds that is required for passing point P, and distance is 6. So the requirement is in a first part, every speed of the car as it passes P. So every speed is total distance over total time. So total distance that is required passing P is 6 and total time is 2. So 6 over 2 will be 3 meters per second. Every speed of the car as it passes Q. So look now, the car takes 0.40 second to pass Q. So it means same distance like the length of the vehicle is required to pass Q. So 6 meter distance is the distance that is required to pass Q, and time is 0.40. So 6 over 0.40 will be the average speed of the Q. Formula used will be total distance over total time. So look now, first and second part. For the first part, 6 over 2. And for the second part, 6 over 0.4. Solve it on the calculator, will give you the answer. So look further now. In the third part, average acceleration of the car between P and Q. So average acceleration is the requirement. So it means the speed at this point is given, that is 6 over 2, and speed at this point is also given, that is 6 over 0.40, which we have find in part 1 and part 2. So initial speed and final speed is given, and okay, 10 seconds later. So it means the time from this to this point is 10 seconds. So average acceleration is v plus u over 2 multiplied by t. The formula is a is equal to average velocity multiplied by time. So v plus u. So this is the u point, this is v point. So look now, this will be the initial speed, this will be the final speed. So it means 3 plus 15 divided by 2 multiplied by 10 second was given. So in third part, the delta v over t, so v minus u over t. So initial speed was given, that was v final speed is 15, initial speed is 3, and time taken is 10. So this is the formula that will be used for finding the acceleration between P and Q. Okay, look at the final part, that is B. Estimate the distance traveled between P and Q. So distance is the requirement now. Acceleration is also given, initial final speed is given, time is given, and distance is the requirement now. So in B first part, look now, distance between P and Q, formula used will be average velocity multiplied by time. So average velocity is u plus v over 2 multiplied by time. So initial speed was given, that was 3, final speed is 15. So 3 plus 15 over 2 multiplied by time is given in the question, that is 10. So solve it on the calculator, you will get the answer. The final requirement is, what assumption did you make when you estimated the distance between P and Q? So the assumption here is, the assumption made is that the acceleration of the car between P and Q is constant or uniform. So this is the assumption that is made in this question. Okay, here is another question. The area under a velocity time graph represents the distance traveled even for velocities that vary non-uniformly. So look at the velocity that is non-uniformly varying as shown in the figure below. The areas below the graph in this case are harder to calculate, but the area under the graph will show the distance traveled in displacement time graph. So area under the velocity time graph represents the distance. Okay, next is the speed time graph. If the graph is of this form, this will show the straight line, so the acceleration is constant. If the graph is of this form, in this case, speed will be constant. And if the graph is with the horizontal line, so object is at rest. Okay, the next topic is the velocity time graph. So here are actually four types of the graphs. One is this is graph 1, this is graph 2, this is graph 3, and this is graph 4. Because graph 1 is a horizontal line which is maintaining its speed at 20 meter per second. So first we are going to discuss this graph. So look now, the velocity remains the same, that is 20 meter per second. As time increases, this means the object has a constant velocity of 20 meter per second. Since velocity is equal to distance over time, or distance is equal to time multiplied by velocity, so we are going to find the distance in first 5 seconds. So distance is actually a figure is like a rectangle. So area under the velocity time graph is showing area or distance. So area under the velocity time graph showing the distance actually. So this is the length and this is the width. So 5 into 20 is the distance. So the body covers 100 meter in first 5 seconds, which can also be obtained by finding the shaded area from 0 to 5. Thus, in general, the area under the velocity time graph gives the linear distance traveled by the object in the given time interval. Now for the graph 2. Here is a straight line graph, but the graph is moving from left to right upward. The velocity has only positive values. This means that the object is moving in only one direction only. The velocity increases uniformly with time since it has a straight line graph. Its average acceleration is constant for different time intervals. In other words, it has a uniform or constant acceleration. So if there is a straight line graph which is moving from left to right upward, the body will have constant or uniform acceleration. The distance traveled by the object can also be found by finding the area under the velocity time graph for whatever time interval that is required. For example, during the first 5 seconds, if the distance is required for the second graph, so the figure is like a triangle. So look now, the figure is like a triangle. So 1 by 2 into base into height. So base is 5 and height is 50. So 1 by 2 into 5 into 50 will give us the answer. So look now, 1 by 2 into 5 into 50, that is the distance from 0 to 5 seconds for the graph 2. Okay, now here are graph 3 and 4. For graph 3, if you see, this is a graph of this form and this is of this form. In this form, the speed is increasing and acceleration is also increasing, and in this case, if you see, the speed is decreasing, like velocity is decreasing, and acceleration is also decreasing, because you can see at this point for graph 4, velocity is greater, at this point is lesser, and at this point the velocity is constant now, like it means the velocity is decreasing. And in this case, here is velocity smaller, here is greater, so velocity is increasing, so acceleration is also increasing. And in this graph, velocity is decreasing and acceleration is also decreasing. So first we are going to discuss graph 3, that is this one. For equal time intervals delta t from A to B, so here is A, here is B, the increase in velocity delta V1 is equal and delta V2 increases, so delta V2 is greater than delta V1. Since A is delta V over delta T, it means A2 delta V2 over delta T is greater than the average acceleration A1 is delta V1 over delta T. So if velocity here is smaller and here velocity is more, so at the same time here acceleration is lesser and acceleration is greater at this point also. So this is the case, and the reverse case is with graph 4. At this point velocity is more, so it means acceleration is more. At this point velocity is smaller, so it means acceleration is smaller. At this point velocity is constant and acceleration is zero now, because velocity is not changing at this point now. So look for graph 4. For equal time intervals delta t from C to D, the increase in velocity delta V3 and delta V4 decreases since delta V3 is greater than delta V4. So it means A at V3 is smaller, is greater than A4. So this means that the average acceleration of the object decreases with time. At point E, the velocity stops increasing and the object from then on moves with constant velocity. So for both graphs 3 and 4, the distance traveled by the object is also given by the area under the velocity time graph. So the area under the velocity time graph shows the distance traveled by the object. Okay, here are some kinds of the graphs. If the graph is of this form, object accelerating. If the graph is of this form, object retarding or decelerating. If the graph is of this one, velocity increases with time but acceleration decreases. If the graph is of this form, velocity increasing with time and acceleration also increasing with time. Okay, moving ahead. Here is a question. A bullet train starts from rest from a station, so starts from rest, and travels along a straight horizontal track towards another station. The graph shows how the speed of the train varies with time over the whole journey. Determine the total distance traveled. So total distance is the requirement. So area under the speed time graph shows the distance. So this is a figure of like this is a trapezium, and the area of the trapezium formula is 1 by 2 into sum of parallel sides into perpendicular height. So this side and this side are parallel and this is the perpendicular height. So 2 to 12 is 10 and 16. So 10 and 16 are parallel sides. So 1 by 2 into 10 plus 16, and perpendicular height is 40. So again listen the formula. The area of the trapezium formula is 1 by 2 into sum of parallel sides into perpendicular height. So after that values will be put in the formula, and area under the graph will show the distance. So this will be the distance. Answer will be in meters. Okay, here is another question. Figure below shows the velocity time graph of the tennis ball thrown vertically into the air. The velocity decreases steadily until the ball reaches at the top of its flight t. So this is the maximum point where its velocity is momentarily zero. The ball then falls back to earth with constant negative velocity since it is now traveling in the opposite direction. Sketch the ball's displacement time graph and calculate its acceleration. Is the acceleration constant before and after t? Okay, first requirement is displacement time graph. Okay, and after that calculating the acceleration. So this will be the displacement time graph of the figure of the question, and now we are required to find the acceleration. So acceleration will be equal to gradient of the line ST. So this is the ST line. So the formula is rise over fall. So 4 over 0.4, because rise is 4 and fall is 0.4. So 4 over 0.4 will give us the answer of 4 over 0.4 will give us the answer of acceleration, because body was moving up, that's why the acceleration is in negative. Okay, here is another question. Consider the velocity time graph in figure for an object. Find A part the displacement after 20 seconds. So after 20 seconds, just you will find the area of the triangle. So 1 by 2 into 10 into 20 will give you the answer. Okay, after 20 seconds, up to this, the figure is like a trapezium. So 1 by 2 into sum of parallel sides, that is 10 plus 20 into 20 will give you the answer of the distance up to 20 seconds. Next is 35 seconds. So after 35 seconds, the point is this. So you will subtract the distance of this portion from the whole portion. So first you will find the area of full trapezium minus area of this smaller triangle that is having base 5 and height 10. So look now in second part. 1 by 2 into 30 plus 10 into 20. So this is the area of the full trapezium, and this will be subtracted because the body is moving in opposite direction, and we are required to find the displacement. So this area will be subtracted. So minus 1 by 2. This is base and 10 is height. So 1 by 2 into 5 into 10. So after solving this, you will get the answer. The third requirement is after 50 seconds. So here is 50. So you will subtract the area of this bigger triangle from the bigger trapezium. So bigger trapezium is this one. So you will use the same values, but now you will subtract the triangle. So 1 by 2 into base is 20 and height is 10. So 1 by 2 into 20 into 10 will be subtracted. Look here. So this is the answer. And the final requirement is, okay, the acceleration. Okay, B part, the acceleration at 5 seconds, 15 seconds, 30 seconds, and 37 seconds. Okay, at 5 seconds, because 5 seconds will be at this line. So use the same rise over fall, 20 over 10 will be 2. So first part answer will be 2 meter per second square. So first part is 2 meter per second square. In second part, acceleration required at 15-second time. So 15-second time will be at horizontal line. So acceleration will be 0. Third part is at 30 seconds. So 30 seconds is here. So rise over fall. So 20 over 10 will be 2. But that will be negative because speed is decreasing. So look now, third part, minus 2. And in the final part, at 37 seconds, so 37 seconds will be at this line. So rise 10 over fall. This is the fall 15. So 10 over 15 will give us the final answer. So 10 over 15. The next question is the velocity time graph for a car is shown below. So this is a velocity time graph for a car. Requirement is estimate the acceleration of the car at A. So at A is the requirement. This is a curve. So we will find the gradient at this point. So we will draw a line that will touch only A point with the help of scale. From there we will draw a triangle. So rise over fall will give us the answer. B part, so B part acceleration will be 0, and at C part is also a curve. So again we will draw a gradient. At this point we will draw a straight line with the help of scale which touches only C, complete the triangle, and rise over fall will give us the answer at C. So look now how. So here is the method. Look now. this is the gradient. We will complete the triangle. Rise over fall will give us the answer of acceleration at A point. Likewise, at C point, a gradient will be drawn. Complete the triangle. Rise over fall will give us the acceleration at C point. And at B point, because the line is horizontal, so at that point, acceleration is 0. So the next requirement is in this question, when the car is at rest, the car is at rest at B point. What is the maximum velocity? The maximum velocity from the graph you can see is 8 meter per second square. Estimate the displacement of the car after 8 seconds. So displacement is the requirement. So you will join O with this point. This is already straight line. So after that you will join this point to this point, and this will become a trapezium. And you will find the area of the trapezium that will give you the displacement. The parallel lines will be 6 to 10, so 4, and that second one will be 0 to 14. So 4 plus 14 will be put in bracket because the area of the trapezium is 1 by 2 into sum of parallel sides into perpendicular height. Perpendicular height is 8. So look now. So displacement is okay. He has made two triangles here. One is from here to here. So this is a triangle. So this triangle plus here is a trapezium. So he has divided the whole figure into two parts. So you may directly solve, and the second method is this one. You may divide the figure in two halves. So here up to here, this is one part, that is triangle, and from here to here, this is our trapezium. So find the area of the triangle and then find the area of the trapezium plus them. That will give you the distance of the graph. Next question is, along a straight road, the velocity of a car changes uniformly from this to this. So this is initial velocity, this is final velocity, time is this. Find its acceleration. This is very simple. B part, the average velocity, because both velocities are given, initial and final. So initial plus final divided by 2 will give us the answer of average velocity. And C part, the distance traveled in 10 seconds. So this is much easier question. So you will solve this question at your home by yourself. So students, this was the topic, important one. Question from this topic always come in the paper. So revise this lecture, understand it, learn it, and make your notes and ready yourself for the exams. Thank you so much.